Alrighty, well, the 6th or 7th time is a charm here. Testing errors. It's been amazing. I started out, I almost had the thing done and made a big mistake at the end in what I said and didn't fix it for a while, and so I thought, well, I'll redo it, and then all sorts of different things happened. Tablet turned off by itself, and I guess it needed to restart for something, and all kinds of funny things happening. But anyway, we're looking at testing errors, and so we want to think about, okay, what's the real world doing? And there's truth. And for our two hypotheses, it could be that H0 is true, or it could be that HA is true. One of those two. And again, because we've got H0 as the one case, and then HA usually, especially for us, is everything else, so that sums up all possible truths. Now we can, by doing one-sided tests, we can kind of, I don't know, we get half-truths or something like that, I don't know. Then we have our test conclusion, and this is based on our data and our rejection criteria and, you know, all that sort of thing, what test we use. And so it could be that we do not reject H0, but it also could be that we reject H0. Okay, and so we do not or fail to reject H0, something like that. And that really gives us 4 ways to look at our real world here. Okay, it could be that H0 is true and we do not reject it, and therefore, hey, we're happy. We'll make a nice smiley face, we put a check mark, we say Yahoo, something like that. Okay, that's great, because H0 is true and we do not reject it. Another possibility could be that HA, the alternate hypothesis, is true and we reject H0. So we're down here, and wow, that's great too. That's a pretty small, poor smiley face, but not everybody's got a great smile, I guess. And you know, Yahoo again, life is great. But in these other 2 boxes, if H0 is true but we reject it, we've made an error. So I'm going to write error over here. And similarly, if the alternative is true but we do not reject H0, that's a problem. That's an error. Okay, we made a mistake. And we call this one up here a type 1, and we call this one down here a type 2 error. And we, in this class, are mostly just focusing on this type 1 error. You have to, type 2 errors are kind of hard to work with and figure out and all those sorts of things, but type 1 errors, piece of cake. We can do that, and in the end we're going to look at how these 2 errors relate to each other. That's what I'm looking for. We'll look at how type 1 and type 2 errors relate to each other, and we'll see to some extent why we mostly just worry about the type 1 error. Okay, so the only way to make a type 1 error is if H0 is actually true. Okay, because you know, the type 1 error is up in this row, type 2 error is down in this row. So we only make a type 1 error if our null hypothesis is actually true. And what we want to do is kind of come back to, a jury and that sort of thing. And so in that case, age 0, innocent. Okay, now if that's really true and we make an error, then we make a type 1 error. And now what does that mean? It means that the person really was innocent, but they went to jail anyway. Ooh, that's bad. Okay, type 1 error sends person, and I'm just going to say punishment because I guess, it could be a fine, it could be jail, it could be community service, it could be something, but it sends a person to punishment. And when we think about it, that's bad, right? We don't like that. We have things like the Innocence Project and so forth. This is bad news, right? So bad news. I would feel very, very badly if I did that. I actually was a juror on a murder trial where we found the person guilty. And, if someday I learned that that person was not guilty, yeah, I would feel terrible. I mean, that would be very, very bad. And so we don't want to do this. Now, ever? Well, I mean, the only way to make sure we never did this is never try them, right? Because as soon as you have a trial, there is the possibility of committing a type 1 error. There's just no way around it, right? So, we have to live with that idea. Now, what are we willing to live with? What proportion of innocence can I, excuse me, can I live with? So, innocence, as in innocent people, can I live with sending to punishment? Okay, that's a great question. How often can I make a type 1 error? And whatever this is, okay, this proportion is called alpha. Okay, so that proportion is called alpha. It is our maximum rate of making type 1 errors. Okay, now for something like juries and murder trials and so forth, we say beyond a reasonable doubt. Well, that's not really quantified, so I don't really know what that is. Maybe that's 0.1% of the time, 1 out of every 1,000. Maybe it's 1 out of every 1,000,000. Maybe it's 1 out of every 100. I don't know. But in our case, for our studies, okay, I don't know alpha for juries. I don't know. To me, that's something one has to talk about and think about, and again, that's, we have words for that, but we haven't actually quantified it, right? We haven't said what alpha is for juries. Don't know alpha for juries. Okay, for our studies, we use alpha equals 0.05, okay, 5%. We are willing to err, okay, so we are willing to make a type 1 error 5% of the time. Now, I think that's something very new to most of you, is setting some sort of threshold. And I think that's why some of this stuff is hard. I mean, it's very easy to state this, hey, I'm willing to make an error 5% of the time. But in particular, when it comes to math, nobody's really said that to you before, right? That oh, hey, you're going to take a quiz, but it's okay if 5% of the time you just fail it miserably. You know, we still think you're a wonderful mathematician or something like that, right? You haven't heard that. That's very new. So this is probably a new concept of, we just set a threshold for errors. We know we're going to make them, and that's that. We set it at that, and that's our alpha level. Now, you know, for the prelude to this module, you were supposed to play the alpha game, and you know, the alpha game kind of sheds some light. Okay, some light on 5%. Now, it's interesting, when I play that game, I tend to get about 10%. Okay, so in a sense, I'm willing to make an error 10% of the time, and you know, so that's not exactly true as to what that alpha game is doing, but it gives us some idea. So for me, you know, when I look at those scatter plots in the alpha game and decide whether there's a trend or not, I tend to pick the ones that are at the 10% threshold and smaller. Okay, so that would say, you know, I'm setting alpha probably somewhere around 10%. Okay, but so in that way, 5%, you know, sounds maybe even better, sounds more likely to not make that type 1 error, right? If you go with 5% instead of 10%, oh, you're making a type 1 error half as much. Okay, but nonetheless, that's what we have. We're willing to make that error 5% of the time, and you know, so that is this thing alpha, and it's what we compare our p-value to. So I'm going to make another page here and look at this p-value and alpha. So remember, p-value is the probability, okay, the probability of observing our data, okay, or extreme. Okay, more toward the alternate hypothesis. But it's the probability of observing our data when, or if, I guess I'll use if, the null hypothesis is true. Okay, so that says, hey, if the null hypothesis is really true, now we never really know whether it is or isn't, but if it is really true, then our p-value is this probability. And so that's why we compare the p-value to alpha, because alpha is our threshold, right? So p-value equals, say, 0.10, 10%, like I said. Well, that's bigger than 0.5%, 0.5, no, 0, I didn't want to put percent on there, 0.05 or 5%, which is our alpha, then we fail to reject H0. Okay, so we fail to reject H0 because it's bigger than alpha. If, on the other hand, we had a p-value equal 0.017, well, that's smaller than 0.05, which is our typical alpha, and so we would reject H0 and go with our alternative, whatever that is. And if we set our alpha at something different, so set alpha at 0.001, 1 in 1,000, that would be really hard to do, to reject H0. But if we set it at that, then a p-value equal, and I'm going to take my 0.017 up there, well, then that's bigger than 0.001, which is our new alpha that we were talking about. And so in this case, we would fail to reject H0. We'd have to just go with it. Now, we may not believe it's true, but we go with it anyway. Okay, and again, that's, bringing this back to the intuition of a court case. Again, we have our court case, and H0 is innocent. Now, what can happen is, I don't know, person was there. Oh, that's some evidence. And that, pushes us toward our alternative hypothesis, because, well, if the person was there, they could have done whatever it was that happened. The person had a motive. Okay, so the person had a motive for whatever happened. Okay, but we have no other evidence. In that case, you see, we probably have not met our alpha threshold. What's alpha? Well, beyond a reasonable doubt, right? So alpha is beyond reasonable doubt. And these two things together, we kind of think, well, the probability, their p-value that comes from this, maybe, so these are not quantitative, but that's the idea, is you don't have to have quantitative to get the understanding of what's going on. And then the quantitative part helps us immensely in just making a quick decision, because here, well, is this p-value bigger than alpha or something? Well, I'm going to say yes. In this case, p-value is bigger than alpha, so we fail to reject innocence. Okay, because we just didn't have enough evidence to get our probability small enough, And again, you have to make that probability in relation to H0. So here, the person's innocent, the person was there and had motive. Does that make the probability that they're still innocent mighty small? No. Who knows? What was it? A big bar fight or something? Well, maybe the person who got the worst of the bar fight was hated or something by many, many people, but only one other person took part, right? And so, it could happen, right? The person could be there, could have had a motive, but didn't do anything. And so we realize that, and so the probability that they are not innocent, is, sorry, I said that wrong. The probability that if they are innocent, could have done these things, well, it's reasonably high, we'll say, right? But, what could reduce that p-value? Well, in addition to the person being there had motive, they found fingerprints on stolen items. Items, so if they stole something, items in the person's car, and they had breaking and entering tools in car, and I don't know what else you might have. But notice this starts adding up, and maybe at some point we say, oh, an innocent person? Okay, would an innocent person have been there, had motive, had fingerprints on the stolen items, those stolen items in their car, along with breaking and entering tools in the car? Oh, that, we can say that match entering method, right? Maybe they have a big crowbar and a crowbar, it looked like some kind of pry bar was used or something like that. Now all of a sudden, hey, we're getting this p-value down there. The probability that we could have pulled from an innocent pool and had all these things happen is really tiny, maybe. And so now we say that's alpha, below alpha, and we reject H0, pick HA, and they're guilty. Okay, that's the idea. For us, it just gets easier with quantitative stuff, because if I can tell you, alpha equals 0.05 and p-value equals 0.03, hey, piece of cake, I got that, reject H0. That's simple. So the quantitative stuff makes this idea way easier to put into practice, but this idea, we can think about it, and we could experience it in our everyday lives of say, being on a jury. And so, this is a little bit more about p-value and the threshold, and what that has to do with, these errors here, right? So this all started with the errors, and we were looking at this type 1 error, and that's where alpha came in. That's our threshold. And then our p-value is our actual probability of making a type 1 error. And so we just ask, well, is that probability smaller than our threshold? And if it is, great. We'll go ahead and reject H0. If it's not smaller than our threshold, we don't want to reject H0. We don't want to make that error because we don't want to make errors that often. And so we fail to reject H0. Okay, so we'll call that good for this one. And then we made it.